The basic building block of modern skyscrapers is the I-beam. Made of extremely dense steel, I-beams weigh an incredible 256 pounds per foot. Cutting them to size requires speed, accuracy, and power. And a steel mill in Columbia City, Indiana has the tool to get it done. The industrial cold saw. 10 feet tall, 23 feet long, and weighing over 55 tons, the cold saw operates with a singular purpose. Cut through the toughest steel on earth like a hot knife.
We manufacture a 50,000 pound per square inch strength material. If you took our largest beam, that single beam can support about 25 elephants. That gives you an idea of just how much weight that material can hold.
The business end of the saw? An 11-foot diameter blade weighing half a ton. Spinning it demands 800 horses of muscle. Today at the mill, a new client needs some steel. 250 structural I-beams cut to 20-foot lengths.
We're absolutely making products that will hold skyscrapers up. We're making beams that will span across bridges and hold hundreds of cars up at one time.
The crew has 8 hours to chop up over 640 tons of steel. They fire up the saw and get ready to cut the first beam of the day. Each I-beam is refined and molded to a length of 300 feet. That's the size of an American football field. Before the cold saw can chop, the beams must be cooled off to 150 degrees. Pretty cold, considering they started life at over 3,000 degrees, hotter than volcanic lava. Once the beams are up to temperature, the cold saw operator fires up the tool and gets his crew ready to eat through solid steel.
We have a cold saw operator who's specifically responsible for operations of the saw, who's getting the highest yield we can out of the process, and making the least number of cuts to satisfy our customer requirements.
The first I-beam section is cut to size in less than 15 seconds. The saw's blade is composed of a material known as high-speed steel. Alloyed with the element cobalt, the blade is highly resistant to wear and heat. This is very important because the saw doesn't actually cut the I-beams. It wears through the steel with one of the oldest forms of energy.
It's actually a friction saw. At that speed, it's actually melting the steel to approximately 1,800 RPMs a minute.
As the saw attacks, the intense friction generated by the blade rubbing against the beam causes the steel to chip away. Slow motion reveals that the friction from the blade superheats the steel to its melting point. 3,000-degree chips of steel fly off the beam. Most of the heat is contained in the chips. As they fly away, they keep both the saw and the beam relatively cool. To demonstrate the ferocity of the cold saw, we've pitted it against its more common cousin, the 10-inch circular chop saw. Surprisingly, the chop saw runs at 4,800 revolutions per minute, almost 3 times as fast as the cold saw. But when it tries to cut through an I-beam, it hits a wall and barely makes a scratch. Slowed down, it's clear that the I-beam easily wins the battle against the conventional saw. In fact, the saw is committing blade suicide in attempting to cut such a solid piece of steel. After just a few attempts, the fresh blade is worthless. So far, the production line is at full capacity, and more than half the day's order is complete. But the client drops a last-minute bomb. They want 50 of the beams to measure a different length, a much longer 54.5 feet. Luckily, the crew has an answer to the problem. The cold saw is shiftable.
The shiftable saw gives us the opportunity to cut multiple lengths to a particular customer's order. That gives us the flexibility to not cut just an 80-foot piece or a 60-foot piece, we can cut a 54.5-foot piece.
The secret of the saw's on-the-fly shiftability is its laser-assisted measuring system.
We have what's called a gauge head on the saw. It's really a movable stop. The movable stop moves up and down the roll line with motors, and we gauge the length with a laser and a reflector. That gives us an extremely accurate indication of how long the product is.
The crew quickly makes the adjustment. Using the gauge head, the crew is now cutting I-beams to exactly 54.5 feet. It now cuts 4 beams to length in one pass. But as the cold saw continues cutting, its temperature rises, and the crew is getting worried.
You know, it's just dangerous, so you got to keep a good ear out so you can shut it down and make sure that you catch it before something bad happens.
Chris and the crew quickly pinpoint the cause of the temperature increase. Steel burrs from the cut I-beams are getting caught in the spaces between the blade's teeth. The spaces are called gullets. During a cut, these gaps fill with flying shards of melted steel. If the steel is not evacuated correctly, the gullets will get clogged. This is called gumming up the blade and can cause the saw to overheat.
Pretty much have to design everything to protect it from the heat.
To prevent damage and delay, the crew uses high-pressure water nozzles to clear out the gullets and cool down the blade.
You have to have a lot of high-pressure water to clean the steel out of the gullets as you're cutting it so that it doesn't ruin the blades. If you're not cleaning that, it's not going to last, and you're not going to have as much production.
With the high-pressure water system cleaning and cooling the blade, the cold saw whips through the last of the I-beams. By the end of the shift, the saw actually came out ahead. It produced an additional 220 tons of structural steel for a total of 860 tons.
Without the hot or cold saw in our operation, we couldn't deliver the customer the length of product that they wanted.
To cut the beams that support bridges and skyscrapers of the future, the steel industry depends on the cold saw.